Hey, Chanhassen Science. This is Mr. Block. Welcome to your second Friday of the year, and congrats on getting through a full week of school. I'm gone. I'm on my way to Michigan with my family for the wedding, and I just wanted to drop this quick video because what we're doing here with absences now is the teachers don't know if we're going to have a sub or if we're going to have a science teacher in the classroom. If for some reason we can't find a sub, then you guys will flex. And so it's a lot easier if we just have you guys listen to me and a video like this, and you can see that we have this capability. So if you're absent or something like that, never want like a quick idea of what we did, just say, hey, Mr. Block, can you drop me a video? And it's really easy for me to do. What are you going to do today? Well, first you're going to watch this video. Number two, there's a reading. It's a 2-page reading. So either you can grab a copy that's in the classroom, or you can go down in the Google Classroom and there's a linked copy there of the reading. And then number three, you're going to answer a Google form that's got some questions about you and then some questions about today. And so if you get those three things done, the video, the reading, and the Google form, then you have finished what I've asked for you guys to do today. So first of all, you can see behind me is a chart, and this was going to be what we were going to be talking about if I was here. And it shows the atmospheric carbon dioxide at the Mauna Loa Observatory. That's in Hawaii. And it goes from 1950 something until just today, right? And you can see on the y-axis, there's this idea thing. It says parts per million. So on the y-axis, which is right here on the upway, and this is carbon dioxide in parts per million of the air. And on the x-axis here is the year. And so this is by year, so time is moving forward on the x-axis. We'll see that that's almost always the case in science graphs. And so what they're trying to do is they're measuring almost consistently the carbon dioxide in the air on this mountain in Hawaii. And you can see that this graph generally shows a zigzag pattern. It goes up and down, up and down, up and down, up and down, up and down. And then if we were to draw a line of like what the average is, well, that average continues to move up and up and up and up as we go forward. So what explains that? And so we're going to look at it a little bit harder on Monday, but the truth is we kind of touched base on this a little bit over the last couple of days. And that is, as the summer months come and the northern hemisphere is where most of the people in the world live, and where there's a ton of the land masses, well, the trees start to bloom and the flowers start to bloom and the grass turns green. And this is when the plants can take over and they can actually start doing the photosynthesis that takes the carbon dioxide out of the air and puts it into the plants. And so normally what we see in the Keeling curve, and this is what we call this is the Keeling curve, is that there is a dip in carbon dioxide during those summer months, that the number goes down. Okay, and that's what the reading will talk to you about, is that the number goes down. And then as those plants die off in November and December, and carbon dioxide in the atmosphere no longer can be sucked in by that gigantic photosynthesis process, then the number goes up. And it keeps going up until March or April, where we see the downturn again as those plants come back and they start sucking in the carbon dioxide. And so we'll watch this video on Monday. It doesn't work very well on my videos to you guys, but it is another way of looking at this. But Keeling noticed that his first year that the number was up and then it went down and then it went back up again. And he was worried that it was going to be crazy up and down and that it wasn't going to show any kind of structure. But as the years kept going, as they kept making these observations, they saw this pattern. And this pattern is an up-down pattern, but a general trend in the upward direction of the carbon dioxide. Carbon dioxide is increasing in our atmosphere. Okay, so that will handle just this slide, and I'll pick up these slides when we come back on Monday. We'll talk about the rest of the slides as we go forward, but this is the main thing right here for you. So once you've watched this video, then go ahead and read the reading about Keeling. Most people attribute this kind of graph and this idea of tracking carbon dioxide to Keeling, and so they call this the Keeling curve. and then go ahead through the Google form and make sure that you answer those questions so that I can get to know you guys a little bit better, and you can tell me anything that I need to know. And then also you can let me know that you followed along on this video. Okay. Once you get done, you're in this classroom. Make sure the teacher knows that once you get done, that your phone is you're done for the day, and that you can let my position is that you can have your phone out, and that if you guys sit quietly and get through the day, I will see you on Monday. All right. Have a great one. Talk to you guys soon.